take a couple of approaches to this question. So first up, it's important to identify that these trapezia are all isosceles. We've got a 60-degree angle here, a 60-degree angle here. Because these are parallel, and we are told that, then this is 60 because they are corresponding, and therefore the two sides, bottom sides of the trapezia are equal. That is enough to say that it's isosceles. If you want to see why a little bit more, then these are co-interior angles now, so that must be 120. They add to 180, and that is therefore also 120. So that is enough for sure to say that they're isosceles. Okay, I'm going to get rid of that information. We're going to use that idea there to help us. So focusing on the top trapezium, because this length is 2, that must mean that this one is 2, because it's isosceles, these two are the same. So just adding some length. So kind of dealt with that, and it's now on the outside. With the 3, we're saying that this is 3, which means that this is 3. Maybe I should just identify the lengths clearly. Okay, brilliant. And then finally with the 6, because that is 6, then that is also 6. All right, now the lengths aren't all next to each other, so there's one more thing I'm going to need to do to help sort this out. So I should have made that one red as well. Okay, and that is to draw one more line in like this, because that creates a triangle here. That's going to be 2, and then a parallelogram, so that is 3. And we've got our side. It's going to be 11, so the perimeter will equal 3 times 11, or 33. Approach number 2, and it's worth staying and watching this, because another time you might think, yep, that I prefer this, prefer this method, and go with it. I'm going to extend the lines through the center to the other side. I ended up having to kind of draw an extra line here in here, and don't be like, this is a little thing to sometimes consider in maths. Just because you're given certain diagram doesn't mean you can't add to it and then use some other facts. Now those lines kind of lose a little bit of the information, the fact that that one is 2, and it was this one that's 3, and it was that one that was 6. Okay, so I'm just going to identify them. Now, for similar sorts of reasons to proving the isosceles triangle, we've got this must be a parallelogram, this shape down here, which means the bottom is 2. And then for the 3, this length is also 3 because this is a equilateral triangle. We could prove that, which means that now we've got a parallelogram at the bottom, and that is also 3. So I'm doing sort of similar approach to before. Then this must be an equilateral triangle, which means that is 6. In a similar sort of way, we see the bottom's 11, and therefore the perimeter is 33.